Hi everybody, I'm really excited to be here as part of the Women on Stage conference, and today we're going to talk about Java and Kotlin. So a few weeks ago, my friend Jean and I were talking, and she told me that she's got this new project and that she's wondering which language to choose, mainly Java or Kotlin. Now, Jean's group is programming in Java, as did I until about three years ago, when I joined Next Insurance and started programming in Kotlin. So I had the background for comparison, but to be honest, the last time I was programming in Java, it was Java 8. And I heard about all the progress that Java has done in the latest versions, so I figured this could be a great opportunity to compare the two and see where they are today. Okay, so hi, I'm Sigal. I'm a software engineer and currently team leader at Next Insurance, and I'm also a developer mom. I consider myself a developer mom, which means my house might be messy, but my code is clean. Okay, so writing code is kind of like riding a bicycle, right? Let's think about a bicycle. What a great invention. It brings you safely and reliably from point A to point B, beats walking, much less maintenance than a horse, cheaper than a car, done its work perfectly. And then sometime later, someone decided it might be a good idea to add a small engine to this bicycle. So now a little bit easier up the hills and a bit more fun. This is kind of how I see Java and Kotlin. They're both JVM languages, only that Kotlin got rid of a lot of boilerplate code and made it a lot of fun to develop and a bit easier to get to the endpoint. Okay, what are we going to talk about today? We're going to talk about three main topics about null safety, type inference, and data classes. And at the end, we'll briefly go over comparison of features and where they are in Java and in Kotlin today. Okay, nullability. The ticking time bomb of null pointer exception, which is probably one of the major causes for runtime crashes. A big headache for Java developers. What can we do about it? So in Java, every object might be null. This means that every time we want to approach a variable or a method of an object, we first have to make sure that it's not null. Otherwise, it will result with null pointer exception. So let's think of an object that contains other objects. How can we avoid null pointer exceptions? So till recently in Java, what did we do? What do we do today? We need to check that it's not null. So every time we go one level deeper, we need to verify that the upper object is not null. Java 8 introduced us to optional, kind of Java's way to add some null safety to the code. What is optional? Optional is sort of a single value container, so it can contain a value or not, and it also adds methods to help us manage and handle this situation where we have or doesn't have value in the optional. This way, we have to keep in mind that the value may or may not exist. So with using the method of the optional, it forces us to think about nullability and helps us avoid null pointer exception. Let's take a look at some examples. So this is how we initialize optional. We can initialize it to be empty, which is like our equivalent to null. We can initialize it to a nullable value, or we can use off and make sure that the value is not null. If it is null, we will result with the null pointer exception. How do we use it? We can use the if present to run something only if the optional has value. We can use the is present to check if there is a value or not, and maybe only that get the value or do anything. And we also handle, we also have ways to handle empty values, similar to null. So what do? We can assign a default value, or we can decide to throw some sort of exception if there is no value. What do we have in Kotlin? So we have few things in Kotlin. First, we need to know that a variable in Kotlin can be defined as nullable or as not nullable. This is done using the question mark. So if a variable has a data type that if we add a question mark after the data type, this means the value is nullable. if we omit the question mark, this means this value cannot hold null. And we can be sure for the entire lifetime of this variable that it will never hold null. And we will never, well, we will get null pointer exception if we try to assign null to it, but it can never be null. One more thing is that the null safety is added. Kotlin is, as we said, is a JVM language, so the null safety is being added to the compiler bytecode. So we don't need to see it in the code, but it's being done behind the scene. Another thing that we have is the safe calls. This means run it only if the object is not null. So this is Kotlin's way to avoid null pointer exception. So if in Java we would call it using only the dot and we would fail, then here we won't fail, it will just return null. So let's see an example. So if we use here a nested object and calling it along the way, it will return the value as it should, or it will return null if somewhere along the way the object was null and no null pointer exception. Another operator is the double exclamation mark. This is used to convert a nullable variable to a non-null variable. So this should be used with caution. Here's an example. If I use it on a non-nullable object, everything is fine. It will convert to a non-nullable. If the variable was null, it will result with null pointer exception. So you need to really be sure that the value, there is a value and it's not null. And last but not least, the Elvis operator. One of the nicest one. What it means is assign a value if null. It's kind of having or defining a default value in case the value is null. If you're wondering why it's called the Elvis operator, it's because the question mark in a column kind of looks like Elvis's hairstyle, or if you don't believe me, I've prepared this. Okay, so this is how it's used. If the left-hand side of this operator is not null, it will return it. If it's null, it will return the right-hand side. Okay, next, type inference. How is type inference being used, or what's its status in Java and in Kotlin? Let's have a brief look. So what is type inference? Type inference is the ability to detect the type of a variable, for example, without having to explicitly define it. In Java, as we know, is strongly typed. We need to define the type of a variable, of a return type of a method, the arguments. We usually define the type. We will see later a little progress. Kotlin, as we said, also compiles to Java bytecode. So obviously it is also strongly typed. But we do use var and val. We don't have to define the type. Kotlin can understand the type. The compiler can understand the type using compile time and just adds it behind, so the code is cleaner. Here's an example. If we have value x and it's assigned a string value, then Kotlin will understand that it's a string. Or if we need to, or if we like to, we can obviously define the type explicitly like that. In Kotlin, we have two types of variables. We have a mutable variable and an immutable variable, which can be initialized only once, similar to final. So to define a readable, let's call it, variable, we use the val keyword, kind of like a final in Java. Otherwise, we use var. Okay, so here's the difference. A val can be initialized only once. The second time will result in compile time error. And val can be changed and reassigned as many times as we like. And we also have inference in methods. We don't have to define the type of the output of the method. It can be understood using the expression. Okay, Java 10 did introduce us to var, did a major step towards type inference. So we have the var, similar to Kotlin, but different. Let's see the differences. So main differences are. First, as we said in Kotlin, we use var for mutable and val for immutable, where in Java it can be either mutable or immutable. You can add the final and make it immutable. We can, in Kotlin, we can use it anywhere we like. In Java, it has to be, it can be only used for local, like local members of a method. And in Java, it has to be initialized on the spot. In Kotlin, we can initialize it later, but then at the declaration part, we have to define the type. Otherwise, the compiler won't know which type to give it. OK, let's go ahead and talk about data classes. What are data classes? Data classes are sort of like data containers or data carriers. They're objects that all they aim to do is hold some data. So kind of like when we take a result set from the database and we only need to keep the data somewhere. I'm sure you have tons of examples of where you use simple, very simple classes that only hold some data. So let's think about the class person. It has 3 variables. It has first name, last name, and an ID. How will it look in Java? So we need to define constructor, equals toString, hash code, getters, setters. This is not even the entire class. A lot of boilerplate code, a lot of things that could be generated automatically. We have to define a lot of code. Kotlin introduced us to the data class, which using this notation, if we use data class to define for a class, all we need to do is define the members of this class, and all the boilerplate code, all the equals, hash code, toString, everything will be just generated behind the scene automatically. OK, Java 14 introduced us to a very similar thing, the record. You can use, it was introduced as a feature in Java 14. It was finalized in Java 16. Very similar, one-liner to define a class, just define the members, and it will define all the very obvious code automatically. Let's see some differences and similarities. So both generates equals, hash code, toString, constructor. Kotlin also gives us the copy method, which enables us to copy one data class to another and only change few of the members. Immutability, which is a big difference in my opinion. Records are completely immutable. All the fields are private and static, private and final. In Kotlin, you can define some of the members as var, so they can be changed later. And also Kotlin gives us the option to add secondary fields. They will not be part of the equals hash code toString, but we can use them in the data class. OK, let's do some comparison. I've made this short list of features. Let's go over it very briefly, because we don't have much time. So what we have here, we talked about nullability, we talked about data classes. Kotlin also gives us coroutines, out-of-the-box implementation for lazy initialization and singleton, and implicit inline functions. Switch and sealed classes were added to Java later on as a progress in the immutable collections area, and type inference, which we've discussed. Kotlin also added us a very cool feature called extended functions, named parameters and default values, which can come very handy. Got rid of the new semicolon checked exceptions, no more of those in Kotlin, and some better string management, which was also improved in Java. So finally, which should Gene choose? So Kotlin is the new cool language with a lot of features, and Java is the senior one, but it's not left behind and adding a lot of capabilities and a lot of improvements. Personally, I have a warm place in my heart for Java, but Kotlin is truly awesome, and it's definitely my favorite. And thank you.